Okay, pre-algebra lesson 70 is about solving direct variation problems, so in the form of y equals kx. So remember that variables that vary directly are going to be proportional. So let's take a look at if we had a number of CDs compared to the price of the CDs, and you had a table showing 1 to 15, 2 to 30, 3 to 45. What we're seeing here is that every single time it's going to be a constant ratio, 15 over 1, 30 over 2, which reduces to 15 over 1, 45 over 3, which reduces to 15 over 1. So every single time we get the same ratio. So price divided by number is going to be our constant. So look for the constant, which is k in this equation. Look for that constant ratio. If it is a constant ratio, then it is a direct variation. Okay, so let's look at example number 1 out of the book. It says that the amount Ellen charges for banquet food varies directly as the number of people that attend. If Ellen charges $780 for 60 people, how much does she charge for 100 people? So what we have to find is that constant ratio, and then we can figure out what it is for more people. So the constant is going to be the change over the number. So it's $780 over 60 is the number of people, and when we do the math we get $13. So now what we want to do is look at the constant ratio, the direct variation equation, which is y equals kx. So the charge is going to equal $13 per x per person. So instead of x, I'm replacing that with 100 because they wanted to know per 100. So it's 13 times 100, which is $1,300. And that seems to make sense because it was $780 for 60. Okay, so that's just example number 1. Okay, let's take a look at example 2. I'll read it. So it says, driving at a constant speed, the distance Maggie travels varies directly with the amount of time she drives. If Maggie drives 75 miles in 1.5 hours, how long does it take her to drive 100 miles? Okay, so here's the problem. The distance Maggie travels varies directly. Now, I wanted to specifically have you write this out because this is the wording that we're looking for. Since this direct variation is new, we want to key in on the key words. We want to know immediately when we're reading a word problem what it is that we're going to have to start working. So varying directly. It's kind of like you look for the word sum and you know you're going to be adding, or difference and you're going to be subtracting. So here, when it says varies directly, we know we're going to be using y equals kx. Okay, so first let's figure out what k is. K is going to be the distance over the time. Okay, or we know that the distance will equal the constant times the time. Okay, and this right here is y in the form of y equals kx. X being time. So as much time as we put in at a constant ratio, we're going to get the distance. Okay, so then she was going 75 went 75 miles in an hour and a half, 1.5 hours. So k equals 75 divided by 1.5, which is 50. So she's going 50 miles per hour. That's the constant, k. So now if we use this formula, then we're going to have the distance equal to 50 because the k we figured out. So the first thing you have to do is figure out what the constant proportional ratio is. And so the constant this time is 50. So I know I'm going to multiply 50 times whatever the time is. In this case, they give us the distance, actually. Let me write this out. So we know we're going to go 50 times the time. Okay, so in this case, actually, they wanted to know 100 miles. So this is the part that we do know. The variable is the time. So 100 equals 50 times t. Let's replace time with t. And then we know we're going to have to solve just like any equation. So we're going to use depot and get 2 equals t. So the time that it will take her is 2 hours to travel 100 miles. That seems to make sense because she went 75 miles in an hour and a half. So it makes sense for her to go 100 miles in 2 hours. Okay, so that is example number 2. Final example we're going to look at is example 3. There were 23 people in line in front of Delia waiting to be helped. 3 minutes later, there were 18 people waiting in front of Delia to be helped. Predict how much longer she will have to wait in line to be helped. So again, this is going to be proportional. So you're looking for the constant, the proportion. We know that it was 3 minutes, so we can use a rate to help us to figure this out per 5 minutes, right? Because it dropped from 23 to 18 in 3 minutes. Oops, I put minutes. I meant this right here should be people. So it dropped 5 people in the 3 minutes. So we already know it's 3 over 5. Okay, now that is approximately 0.6 minutes per person. So now we have a constant, approximate rate. Okay, so then we know y is going to equal 0.6 because that's our k. So this is equal to k, the constant. So it's 0.6 times whatever x is, and this time x is going to be 18. So 0.6 times 18 is 10.8 minutes. So it's going to be approximately 10.8 minutes, or actually approximately, if we rounded that to 11 minutes, estimated wait time. So 11 minutes. So I found k, and then it says to predict how much longer. So for 18 more people, we go times the constant rate and figure out what the wait time was, which was approximately 11 minutes. Okay, so that's it for lesson 70 for pre-algebra.